Hello everyone, welcome to another episode of the Microsoft Healthcare Bot. My name is Ganesh Radhakrishnan and I am an Azure Apps and Infra Cloud Solution Architect in the Microsoft Healthcare and Life Sciences team. Today I'm going to give you a quick 5-minute overview of the Healthcare Bot reference architecture. It's important to understand the key components of the architecture, why they are needed and how they should be configured for high availability and fault tolerance. This reference architecture is the result of the work and the solution which Microsoft implemented for one of the biggest healthcare providers in the Northwest region. The Healthcare Bot service is a multi-region, highly available and fault-tolerant software as a service solution. However, the Healthcare Bot requires additional Azure services for interacting with end users, storing COVID-19 FAQ models, distributing and routing incoming chat requests to services that are deployed closer to end users, and so on. Therefore, provisioning this solution architecture entails deploying necessary and required service components in multiple Azure regions. Now let's quickly dive into the operational architecture of the Azure Healthcare Bot service. The web chat client application is used to authenticate and bootstrap end-user browser sessions with the Azure Healthcare Bot service. For authenticating the end-user browser session, the chat client exchanges a web secret for an ID token from the bot service and forwards the token to the browser. This is depicted in step 5 in the diagram. Once a user is authenticated, a persistent WebSocket connection is established between the web browser and the HealthBot service endpoint. This connection is then used for the entire duration of the user's chat session with the bot, and this is depicted in step 6 in the diagram. The web chat client is a Node.js web application and is deployed in an Azure App Service. The App Service itself is deployed in 2 geographically dispersed Azure regions to ensure the chat client service is highly available and fault tolerant. As you can see in the picture, the web chat client is actually deployed in region 1 and in region 2. An Azure Traffic Manager instance deployed within a global namespace is used to distribute the incoming web chat requests between the 2 chat client app services, as shown in the picture. The Traffic Manager maintains heartbeat information on the 2 app service instances by polling them periodically. In the event one of the app service instance becomes unavailable due to an outage in an Azure region, the Traffic Manager starts routing chat requests to the app service instance in the secondary or the paired Azure region. As a result, the Traffic Manager provides high availability and fault tolerance and ensures there is little to no downtime for the web chat client application. For customers wanting to deploy pre-built HealthBot templates such as COVID-19 FAQ published by the CDC, additional app services have to be deployed. As shown in the architecture diagram, the Q&A Maker runtime exposes a REST API and is used to serve COVID-19 FAQs. This API is in turn invoked by the Healthcare Bot to respond to end-user queries on coronavirus. The Q&A Maker runtime also runs within an Azure App Service, as you can see in the diagram. The Q&A Maker app service is deployed in both region 1 and in region 2. 2 instances of the Q&A Maker runtime are deployed in 2 geographically dispersed Azure regions to provide for high availability and failover. The COVID-19 FAQ documents are in fact stored in an Azure Cognitive Search index. Each Q&A Maker app service instance is backed by a knowledge base that resides in the Azure Cognitive Search instance. Since we have deployed the Q&A Maker app services in 2 separate Azure regions, we have to deploy the associated Cognitive Search instances in those 2 regions as well. Finally, the Azure function shown at the top of the diagram is used to synchronize the COVID-19 FAQ knowledge bases across the 2 Cognitive Search instances, Cognitive Search instances deployed in the 2 regions. The Azure function can either be invoked manually via an HTTP trigger or configured to run at predetermined intervals using the timer trigger. Both triggers are configured with the Azure function. Lastly, customers can easily deploy this reference architecture by using the Azure Resource Manager templates provided in this GitHub repo. The ARM template provisions all required PaaS services within a single Azure resource group. After the deployment process finishes, users have to complete a few manual steps to reconfigure the Q&A Maker app service instances. Post-deployment steps for executing the Azure function and configuring the TLS certificates for encrypting the web traffic to and from the app services using SSL are described in detail in the GitHub repo. With that, we come to the end of this episode. Hope you found this overview helpful. Please feel free to leverage the ARM template for deploying the Microsoft Healthcare Bot for your customers. Also feel free to share this video series with your colleagues and teammates. Thanks for watching.